News, and I am your host. And today we have a very disturbing report today about the future of mankind, and no, it has nothing to do with those current wars that are happening in Europe and the Middle East. Um, you see, scientists have discovered that an asteroid they call Idiom, as seen on the projectile behind me, it is on a trajectory to hitting Earth as we speak, and is so deadly it will wipe out almost all life on Earth.
Now that's a lot of damage!
Just to be true, right? Well, before you say this is cap, allow me to bring out the evidence. For instance, you see, this has happened before in the past, specifically like 65 million years ago, so it can most definitely happen again. I probably don't believe me, but let me finish. So, first of all, scientists have discovered a brand new metal inside the soil called iridium. Now, you're probably wondering, okay, there's 23 different types of metal found in the soil. Nobody cares about iridium. Well, you see, iridium is no ordinary metal on Earth. In fact, it's not even from Earth. Iridium is a metal found inside of asteroids that have hit Earth, otherwise called as a meteorite. And scientists can actually tell how old this rock is, or should I say, my bad, metal, by how deep the rock is from the soil. And you see, this specific piece of iridium was exactly, according to scientists, 65 million years old. Dang, that's old. So the second piece of evidence is this graph right here. So as you're seeing that these right here, these random types of colors, this is soil levels. And this is where this is higher soil levels because the colors are lighter, indicating sand and dirt. These are darker, indicating more rocky and darker shades of soil. So this is the higher points of the graph. So you see, if you're noticing here, there is a ton of fossils, like a ton of them. Then this random red line appears, and then there's just there's like little, like seashells basically. These can basically be considered seashells. So you see, something happened at this red line that caused a ton of fossils being made to like absolutely none being made. What you can also notice is that these fossils are more detailed. You can see animals that you can kind of see like a lobster sort of looking thing here. But then everything here just looks like shells, which is pretty interesting. Alright, so the third piece of evidence is on this line, on this other graph here. You can see it's labeled diversity versus time. Now, you see, you can notice that this is about biodiversity, and at the bottom here you're seeing these numbers, which is indicating the number, and then it's supposed to indicate million years. So this would be 5 million, 4 million, all the way down to today. So as you can see, it's going up and down, and you're seeing these red arrows are indicating a massive extinction inside a population. So and it's still going up, and then we're having a big uprise, and then suddenly, boom! The biodiversity basically splits in half. And yours are seeing here, it's labeled 65 million years ago, the end of the dinosaurs. So this is basically what I'm noticing here is that it says 65 million years ago, and there was a massive extinction to the dinosaurs. What's interesting is that iridium that we found a while ago was just as old as this extinction. So all this evidence is showing that an asteroid caused a massive extinction, like an absolutely ginormous one. Since the evidence shows that the material iridium, which is found inside of meteorites, is just as old as a massive extinction that wiped out half of the biodiversity mostly dinosaurs, which is called the dinosaur extinction, and it happened at the exact same time. It's definitely not a coincidence. So now that you believe me when I say there's an asteroid called Edium coming towards Earth, it will cause a massive extinction and kill us all if it hits us. Allow me to bring some hope and relief to tell you that there is a 100% definite solution to this problem. This here is our Minecraft representation of the situation of science. Now you see, here's the sun, here is our Earth, and here is Iridium. You see, so a couple of background information about Iridium is that Iridium is 6.89 billion kilograms and is heading towards Earth at 103,450 kilometers per hour and is currently 904.7 million kilometers away from Earth. If you do the math correctly, we have roughly 116.03881279452 years until that asteroid hits us. And wait, I am not done.
No, God! No, God, please, no! 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 No!
If this asteroid is moving the 104.7 million kilometers towards Earth, it will take, as said, 116 ridiculous decimal years until it gets to where Earth was. Notice I said was and not the word is. Here's the thing. Earth does not stay in one place. It moves around the sun's gravitational pull, or also known as an orbit, and according to math and science, Earth makes a full rotation around the sun every year, meaning Earth will rotate around the sun 116 times before the asteroid hits us. But what about that 0.038812794452 of an Earth's rotation? Circumference or distance the Earth travels around the sun is 940 million kilometers. If we round that ridiculous decimal, I'm just going to say 0.038 to just 0.04 or 4%. Percent that's percent of the Earth's orbit around the sun. And since one rotation is equal to 1 year, that ridiculous percentage is not only the percentage of a year the Earth is traveling, but the also percentage of the distance is also adding to. And also is 4% of the Earth, since 4% of the Earth's orbit, 4% of 940 million kilometers is 37.6 million kilometers, which would mean that after Earth rotates the 116 times around the sun, it's going to show up at the exact same location it started when the asteroid began coming with Earth. But that 4% is going to move about to right here. So when I said was instead of is from before, this was where Earth originally was when the asteroid began going towards Earth. And this is where Earth is after it's moved once the asteroid hits us. Don't worry guys, the asteroid is not going to hit us. Also, Newton's first law of motion explains that object in motion will stay in motion unless acted on another force. And according to research, the sun has more gravitational pull than Earth does. The reason is because the sun has much more mass than Earth. So, you see, when the asteroid is coming up towards Earth, the Earth is going to be moving the 37.6 million kilometers around the axis. And the sun is going to be the sun's gravitational pull is going to be pulling Edium towards the sun, not towards Earth, because it has more gravitational pull. And because of that, the sun's gravitational pull is going to be increasing the distance between Earth and Edium. And also, did I mention that EDM's longest length is 78 kilometers? That is not even 1% of the distance that Earth is going to be moving. And by this math, I can safely say that by the time EDM travels the 104.7 million kilometers, it reaches where Earth was when the 116.038 years timer started. Earth will be 37.6 million kilometers away from that point. And EDM is going to miss us, or the sun is going to have some lunch. So, as an example of when an object is moving, it doesn't necessarily mean it's going to land in that exact location. So, imagine this arrow is EDM, and that guy right there is Earth. Even though I have my bow pointing at him, he's moving, just like how Earth would be moving around the axis. And so, when he's moving, despite my cursor being on him, he still has plenty of time in order to dodge my arrow attacks. And that's just like how Earth will naturally be able to dodge EDM's asteroid attacks. So you're probably wondering, what would happen in this procedure in the event that your calculations are wrong? Well, you see, in the very tiny 0.000000000
2,000 years later.
0.00001% chance that my calculations are wrong, we'll be sending nukes into space to destroy the asteroid. Now, allow me to explain how nuking the asteroid will be extremely effective. Now, you see, in order for me to explain this, I'll have to go ahead and explain to you one of my favorite history projects and events of all time, World War II. So, you see, there's this town inside of Japan called Hiroshima. During World War II, Japan was part of the Axis powers, fighting the United States, Great Britain, and a bunch of other countries. And you see, after Germany and Italy surrendered, Japan was the last one. At one point, Japan had lost all of its territories that it had conquered in the Pacific due to the United States, Britain, and Australia. And yet, despite it losing all the battles, it decided not to surrender, and so the US decided, you know what, we're going to drop a brand new crazy bomb called the atomic bomb on them. They attacked two cities, Hiroshima and Nagasaki. And you see, you'll understand why this makes sense towards asteroid collision and how to prevent it. So, you see the size of Hiroshima is 905.01 kilometers squared. And you see, the longest length of EDM is 78, meaning that its full kilometer squared is nowhere near as big as Hiroshima's. So here's a little before and after picture of the bombing of Hiroshima. So before, we see a ton of buildings, like a lot of agriculture and architecture. What am I saying? Architecture, not agriculture. So a lot of architecture and everything with the buildings. And then before, literally just ruins and all of this stuff. You can see a humongous difference. The bombing destroyed everything in that 905 kilometer radius. Well, except this building right here. This building is strong. So as you just saw with those images, the atomic bomb, or also known as a nuke, absolutely obliterated that 905 kilometer squared area for Hiroshima. Now, can you just imagine here? That is a massive distance for the nuke to do so much damage. And it reminds you once again that EDM is nowhere near as big as Hiroshima. So nukes are going to literally one-shot that thing into being absolutely nothing but powder and decay. Okay, so what? The nukes will actually absolutely obliterate the asteroid. In what chance do you think they're actually going to reach the asteroid? Won't they just run out of fuel and then they'll just droop down? And you see, there is evidence that this will still work despite of your little concern. So you see, according to recent times, if we read, just read right here, from 4 years from now, NASA and the United States are going to be actually sending in a nuclear-powered rocket engine into space, basically a nuke, into space to see if it'll actually reach the distance. And so, according to the scientists, since these are actually big-brain scientists and not just some middle school kid, these people know what they're doing. And so, this is showing that rockets are able to reach into space, especially nuclear-powered ones. So, here is our Second World War II reference. I want you to imagine this. You are Nazi Germany, and you're currently losing every single battle. You're losing soldiers and arms, left, right, and center, and the Allies have breached both the Eastern Front and the Western Front borders. So, what would you do in this sort of situation? Usually, you'd probably surrender. However, Hitler's solution was to create these things called V2 Vengeance rockets. You see, these things are basically the granddad of airstrikes. Basically, during a test launch for these things, one of them ended up going so high it went into space. It went a little bit of a distance inside of it, then went back down into the Earth. It burned up and exploded before it even got into Earth, even hit Earth. So they're basically useless. So they ended up changing it so it didn't go that high up, so it actually was effective. Except it really wasn't. It didn't really explode that much. But anyways, my point here is that in 75, 80 years ago, if Germany 80 years ago was able to make a rocket that could go all the way into space and keep going for a little bit, can you just imagine with modern technology how far airstrikes can go? And we're not even going to be using airstrikes, we'd be using nukes in order to fully one-shot that asteroid. So with all this evidence, we can most definitely say that nuking the asteroid is an efficient way because it's able to reach the asteroid, plus it'll one-shot it without using mineral resources. However, I still agree with my first solution is a better solution. So with all of this evidence explaining how we are completely safe from this asteroid, now, I, for one, don't think we do need to send nukes into space, because, after all, my calculations are correct that the EDM is actually going to completely miss us by 37.6 million kilometers. So, we don't even need to waste resources sending them up. But, in case those are incorrect, once again, very low percent chance that they are, we'd be sending nukes up there, and according to evidence from World War II and modern technology, these nukes are perfectly capable of destroying the asteroid and saving us all. So, thank you guys so much for watching my TED Talk. Mic drop.
Is it too much to pick myself up from the